Ladies and gentlemen, in today's discussion we're going to discuss this paper that has been given unto us. So the first question reads to say, define managerial economics. Give two brief examples where managerial economics helps managers to address business challenges. So in layman's language, managerial economics is simply a subject of study where we apply economic theory and quantitative methods to business decision making. So the examples that are used where the manager can address business challenges are quite a lot. We have one, management decision problems. A manager can apply economic theories in such an environment because under these management decision problems we have what is called make and buy, production techniques, internet strategies, and a wide variety of examples you can give, product price and output being one of them. Another example you can give are also economic concepts where we look at theory of consumer behavior, theory of the firm, theory of the market, structure and pricing. Another example you can give is decision sciences where we look at numerical analysis, statistical analysis, forecasting and many others. So that is how basically question 1 can be handled. You make sure you go directly to what they want. So number 2 says, what is produced according to the production function, where quantity produced is equal to 150, L is labor, and K is what? K is capital, according to the factors of labor, the factors of production, sorry. Remember, the factors of production are quite a lot, but in this particular example they have only given us 2, that is labor and capital. One of them, if they give us, we also have entrepreneurship together with technology, which is coming on board. So how much is Q when L? So we just substitute. So when L is 32, okay, my surface seems not to be okay. Okay, when L is 32, so 0.3, and K is 4, 0.4. So you just get your calculator. So you punch 150 open bracket, 32 to the power 0.3, close bracket, open bracket, 4 to the power 0.4, close bracket. You will get your answer to be 738. 738.7. So this is how much is produced when labor is 32 and when capital is 4. Then we have B. What would happen if the production, what would happen to the production if you reduce labor by 25% and increase capital by 50%? So what is 50% of this guy? It is 2. 50% of this guy is 2. Remember, they've said increase by, so 2 plus 4, it will go to what? 6. Then what will happen if labor is reduced by 25? So what is 25% of 32? So 25% of 32 is basically what? 8. So you can just multiply 32 by 25%. You will get the value to be 8. And 8 minus 32, you get the value to be 24. So the new value you are going to use in this particular case is 24, maintaining the same solution. So we have 150, then we say 24 to the power 0.3, and we say 6 to the power 0.4. So we say 150 open bracket, 24 to the power 0.3, close bracket, open bracket, 6 to the power 0.4. You get the value to be 796. So the value is 796.9. Remember, the question says what would happen to Q. So if we check the production as what? Increased. That's what would happen to Q. We can also give the margin by what is the margin percentage of which Q has increased with. So it is basically what? 58.2. So this is the margin of which the production has increased. Is this an increasing, decreasing, or constant returning to scale? So for you to just determine whether it is an increasing, decreasing, or constant return to scale, you check the powers that are given here. So you add these powers, 0.3 plus 0.4. They give you what? They give you 0.7. And if you check, this answer is lesser than what? 1. So if the answer we get is lesser than 1, which means that the equation we are given is a decrease returning to scale. So in another way, if you want, you can have these inputs here by 50%, meaning you're going to use 16 and you're going to use 2. So by arithmetic calculations, we can say, remember we're halving these guys by 50%, so meaning 32 will go to 16 to the power 0.3 to the power 0.3, and 4 is going to 2 to the power 0.4. You are going to find the answer to be 454. And if you check 454.7, if you are going to multiply this by 2, it will give you 909. And if you check, this answer is below 909. That will also tell you to say that you are dealing with a decrease in the returning to scale. And this is one of the shortest way in also finding the decrease returning to scale. Now we are done with the second question. We go to the third. So a firm demand function is given by P is equal to 400 minus 4Q, and the total cost function is basically 420 plus 10Q plus Q squared. How much should the firm produce if the objective of the firm is cost minimization? So when we're talking about cost minimization, meaning we're talking about average cost being equal to what? Marginal cost. Remember, when average cost is greater than marginal cost, then it is what? Falling. But if average cost is less than marginal cost, then it is what? Rising. Then when marginal cost is equal to average cost, then we achieve what is called the average cost minimization point. So in this particular context, the demand function has no use. So our main function is the total cost function. So what do we do here? So what we can do is, from the total cost, you can find the total average cost, which is equal to total cost divided by what? Divided by quantity. So it will be 420 divided by Q plus 10Q divided by Q plus Q squared divided by what? Divided by Q. So this will be equal to 420 divided by Q plus 10 plus Q. So this is the average cost function. Then from the average, from the total cost, we can also come with the marginal cost. Remember, marginal cost is simply the derivative of total cost over the derivative of what? The derivative of quantity. So what is the derivative of 420? 0. What's the derivative of 10Q? It is 10. And what's the derivative of Q squared, which is what? 2Q. I will paste a link in the description of this video so that you see how differentiation is being applied, because this is simply the concept of differentiation that we learned under our basic mathematics, either ordinary or advanced. So from here, remember, we are talking about cost minimization. minimization. So average cost should be equal to what? Total cost, meaning it will be 420 plus 10 plus Q. Remember here it is over Q is equal to 10 plus 2Q. Then from here, for us to be able to remove this Q from the denominator of 420, we multiply this by Q, the whole lot of this expression. So Q times everything. Here we will remain with 420 plus here we will remain with 10Q plus here we will remain with Q squared is equal to this times that we remain with 10Q plus here we remain with 2Q squared. So this is positive and this is positive, they can cancel out. So we remain with 420. So we remain with 420. Okay, we remain with 420 equal to, so 420 equal to, then we have 2Q squared minus Q squared. So it will be 420 is equal to Q squared. And since we are finding the value of Q, you can introduce square root both sides. And this side square root. So it will be the square root of 420, which will be equal to 20.49. So this is the production when we look at cost minimization. Okay. This was a long run, very simple question. Simple question. Okay. Okay. So we go to number 4. Number 4 says how many units of X and how many units of Y the firm has to produce to get maximum profit. Remember, this is the question. Suppose that the firm produces 2 goods, X and Y, X being chairs and Y being tables respectively. The profit function is given by that. So let us discuss deep on how we are going to solve this particular question here. So what are the major steps to take? So when you look at this particular question, you understand that it has 2 unknown variables in it, and you cannot differentiate a question with 2 unknown variables the same way you differentiate a question with 1 variable. So what then do you do? So for you to know exactly what you are going to do in this particular question, you are going to apply what is called partial differentiation, where we have d pi over dx. Remember, in my previous video I also had to teach how to use partial differentiation. So how do you apply partial differentiation on this question? You are going to apply partial differentiation on this question. Since you are differentiating x, you hold y constant, so it will be negative 2x here. So since you are holding y constant but there is no x, which means that this is 0, then you go to the next one, it will give you what? 6. Since you are holding y constant, here there is no x, meaning this whole expression is what? Is 0. So remember, for you to achieve maximum profit, d pi over dx needs to be equated to what? 0. So it will be 0 is equal to negative 2x plus what? 6. So it will be 2x equal to 6, then the value of x will be equal to 3. Then we differentiate in respect to y, holding x constant. So it will be d pi, or d profit over dy, to be equal to, since we are holding x constant, here there is no y, meaning this is 0, here to give us negative 4y. Since here there is no y, meaning this is 0, then it will give us 8. Remember, the profit over dy, it is assumed to be 0. For us to achieve maximum profit, it will become negative 4y plus 8. Grouping like terms, it will become 4y is equal to 8. So 4 here, 4 there. So y is equal to what? Y is equal to 2. So how much is the profit level? So the profit level in here, we just say profit is equal to, so where there is x, we put 3 minus squared minus 2. Where there is y squared, we put 2 squared plus 6, 3 plus 8, 2. So this here is negative 9, and this here is 4, this here is 18, and this here is 16. So here it will be negative 9 minus 8, then plus 8 plus 16, it will give us 34. Then we have negative 9 minus 8 plus 34, it will give us 17. So 17 is the profit level we get when the number of tables is 2 and when the number of chairs is 3. So this is how we were going about this particular question that we have been given.